Again, another video where I'm just kind of dubbing sound over it. Alright, derivative is rates of change. So we know of an old rate of change, which we would often call slope, generically called slope. That's now what we call an average rate of change. Okay, so if we have this function, we're going from 5 to 6 on the x, or the t in this case, right, the average rate of change. So it doesn't really say what this represents. Usually with t, it's like as time moves, its distance. Maybe a ball is thrown up in the air, or a pendulum is swinging, whatever it might be. Okay, so average rate of change, that's just slope, f of b minus f of a over b minus a. That means, right, old slope, y2 minus y1 over x2 minus x1. So our x's is the 5 and the 6. The y, we need to substitute 5 and 6 in there to get the y. So when we substitute 6, 6 squared plus 3 times 6, I kind of wrote under that little parabola line that I drew there, we get 47. And then when we substitute 5, we get 33. So 47 minus 33 over 1, we just get 14. Now, usually we're talking some sort of distance, so we'd have units, and that's why I wrote 14 units over some sort of time, like feet per second, whatever it is, but they don't give us anything here. Okay, an instantaneous rate of change, that means like at that given second, at 5 seconds or 5 minutes, whatever the unit is here, how fast is this thing moving? Okay, what is the rate of change? So that just means do the derivative and then substitute whatever value they give. These are typically easier, like you have to learn derivatives, but after that it gets easier as the math progresses. So the derivative t squared is 2t, the derivative of 3t is 3, and the derivative of negative 7 is 0. Substitute 5 in for that t. 2 times 5 plus 3 is 13. Again, whatever units they give. Alright, this next example I have is actually the math behind it. Like, oftentimes the hard part of math is writing in and understanding what it's saying. So I wrote these formulas here that they give you in the book, and you're more than welcome to use it. You're not going to see this problem pop up too often. It might show up in a quiz. But anyways, here's what's going on. F of 100 is 5,000. So they're saying, at 100, whatever this problem is representing, the value is 5,000. The derivative at 100, so derivative, remember, means rate of change. So it's changing at a positive 10 at that given point, at that given time, or whatever this is. So to evaluate f of 101, that would mean it's increasing by 1, and the rate of change is 10, so we would just add one of those 10s and get 5,010. I wrote up the formula there. It says to take your f of a and then plus f prime of a times h. So what is h? Well, h is 1 because we increase from 100 to 101. Again, though, kind of understanding this is a lot easier. For instance, let's look at b. I know I wrote some math there, but I'm increasing a half, right? So instead of increasing the full 10, I'm only increasing 5. The rate of change is 10 for every 1 unit at that given time, and we have a 0.5, so I'm increasing 5. Now you can look at the formula there and see how it's done using it, but that's the gist of this. Remember, these are estimates as well. So at 99, I went back 1 now, right? So if I've dropped 1 and it was changing by 10, then approximately I should drop 10. So 4,990.